The Python ecosystem has powered machine learning for over a decade. PyTorch, NumPy, scikit-learn, these tools built the modern AI era. But every foundation has cracks. Python's global interpreter lock, its memory overhead, its runtime-only error detection, these aren't minor inconveniences at scale. They're fundamental constraints. And in 2026, one organization has decided to stop tolerating them. OpenAgents just announced Psionic, an open-source, Rust-native machine learning framework. Their mission statement is blunt: Python sucks. It's time to get the ecosystem onto proper languages like Rust. Today we're breaking down exactly what that means. Let's start with the actual problems. Python's GIL, the global interpreter lock, prevents multiple threads from executing Python code simultaneously. In a world of 16 core CPUs, this is a serious constraint. Yes, PyTorch's tensor operations run in C++ and CUDA outside the GIL, but the model definition code, the training loop, the data pipeline, all single-threaded Python. Python 3.13 introduced experimental free-threaded mode, but the ecosystem hasn't adapted. Beyond threading, Python is slow. Every variable is a heap-allocated object. Every function call carries interpreter overhead. The ML community solved this by offloading hot paths to native code, but that abstraction leaks constantly. And Python's garbage collector introduces unpredictable memory release at exactly the wrong moment, when your GPU VRAM is nearly full and you need deterministic cleanup. Psionic is OpenAgents' answer. A machine learning framework written entirely in Rust, no Python dependency, no C++ extension modules, no garbage collector. It aims to replicate what PyTorch provides: tensor operations, automatic differentiation, model definition, training loops, and inference. But Rust all the way down means true parallelism, zero-cost abstractions, compile-time memory safety, and predictable performance. The name is evocative: psionic powers operate beyond conventional channels. OpenAgents is betting that psionic can do things the Python ML world simply cannot, not because the math is different, but because the substrate is. Early benchmarks show psionic already outperforming Python ML equivalents. And a major announcement alongside psionic: they're porting Apple's MLX framework, the one designed specifically for Apple Silicon's unified memory architecture, into psionic's ecosystem. That means M1 through M4 Ultra chips, with their unified CPU-GPU memory pools, become native targets for Rust ML. Psionic isn't entering a void. The Rust ML ecosystem has been maturing for years. Hugging Face's Candle framework is already production-ready for inference, running transformer models at speeds competitive with Python plus PyTorch, with no Python dependency. Burn is more ambitious. A full deep learning framework with multiple backends, including WASM for browser inference and CUDA for training. Burn has demonstrated training performance on par with or exceeding PyTorch on certain architectures. So where does Psionic fit? If Candle is inference first and Burn is a general deep learning framework, Psionic is built for something neither of them does: distributed training across machines that don't trust each other, with Bitcoin as the settlement layer. That's a fundamentally different problem, and Psionic's unique position in the Rust ML landscape. Here's where OpenAgents' vision gets genuinely novel. In April 2026, they're running a decentralized model training event. Contributors can plug in their GPU, an RTX 3090, a Mac Studio with M4 Ultra, a gaming rig that sits idle 18 hours a day, and get paid in Bitcoin for their verified compute contribution. No AWS account required. No custom token to speculate on. Real Bitcoin. The model works like this. Contributors register their hardware, Psionic's distributed coordinator assigns gradient computation shards, contributions are verified cryptographically, and Bitcoin is paid out proportional to verified work. The technical challenge is Byzantine fault tolerance, detecting bad or adversarial nodes in a gradient aggregation pipeline. OpenAgents is drawing on federated learning research and distributed systems techniques that have been studied for years but rarely deployed at this scale. Why is 2026 the right moment for this? Several trends are converging. Bitcoin's Lightning Network has matured, micropayments to individual contributors are now practically viable. Rust's async ecosystem with Tokyo makes building reliable distributed systems dramatically easier than it was even 3 years ago. Consumer GPU supply has recovered from the 2022 shortage. Millions of RTX 3000 and 4000 series cards sit in gaming PCs, idle most of the day. And modern distributed training algorithms like DaiLoCo have reduced bandwidth requirements by orders of magnitude. You no longer need data center grade networking to train collaboratively. The combination of Rust performance, Bitcoin payment rails, and low communication distributed training creates a window that simply didn't exist before. Psionic isn't a standalone tool. To understand why OpenAgents built it, you have to see the full stack. At the bottom, Psionic, the Rust ML layer. Fast, memory-safe, portable across hardware. Above it, the OpenAgents network model, released March 3, 2026. The ONM is the only agent framework with both model context protocol and agent-to-agent protocol support natively, simultaneously. It defines a shared language for agents to discover each other, verify identities, communicate, and exchange resources. Above that, Bitcoin, the settlement layer. Not a custom token, not stablecoins. Bitcoin via Lightning for trustless payment between agents and compute contributors. Put it together, models trained on the decentralized network, deployed as agents on the decentralized protocol, paid for via Bitcoin. A vertically integrated decentralized AI infrastructure stack, with no single point of control. Let's spend a moment on the ONM, because it's the coordination layer that makes everything else work. The OpenAgents network model defines 7 building blocks. Events, everything is an event, a single primitive that handles all communication patterns. Networks, bounded context that scope agent interaction, so events don't leak between systems. Progressive verification, from anonymous at level 0 to full W3C, did cryptographic identity at level 3. Agent identity using W3C, did standards, and JWT tokens, resources that agents can expose and consume. Native MCP and A2A support, the only framework doing both simultaneously. And Bitcoin settlement via Lightning for agent-to-agent payments. When you combine the ONM's agent coordination capabilities with Psionic's ML compute layer, you get something new. AI agents that can train models, offer inference as a service, and pay each other in Bitcoin, all within a single coherent framework. I want to be transparent about where this coverage comes from. I'm actively testing OpenAgent systems, the ONM, the agent interoperability layer, the Bitcoin payment flows. The early signal is real. Agent interoperability across different frameworks isn't just theoretical. The MCP and 8-way protocol support works. The Bitcoin payment layer works. What I can't yet test is Psionic's distributed training at scale. That's what April's training run will demonstrate. So this is first-hand reporting, not repackaged press releases. When I say the agent stack shows promise, I've run the code. When I say the April training run is the key test, I mean it. Decentralized training at meaningful scale is hard, and the April run will be the first real stress test of whether the full vision holds beyond a demo. Let's be honest about the risks. Ecosystem inertia is real. PyTorch has years of model checkpoints, tutorials, and tooling. Rust's learning curve is steeper than Python's, and the ML community skews toward researchers, not systems programmers. Distributed training at scale has genuinely unsolved problems. Node churn, Byzantine gradients, network partitions during long training runs. And the ML export is announced but not yet delivered. Apple Silicon support adds platform-specific complexity. Can Rust reach PyTorch's library ecosystem depth? That's a multi-year project even with significant community momentum. But here's the thing, Psionic doesn't need to replace